We want to find when the function y equals x cubed is closest to the point 2, 0. Let's use the distance formula. D equals the square root of the quantity x minus x1 squared plus the quantity of y minus y1 squared, where d is the distance from the function to the point x1, y1. In this case, x1 is equal to 2 and y1 is equal to 0. Substitute the values 2 for x1 and 0 for y1 into the distance formula. Recall that y equals x cubed, so rewrite the equation for d of x into a single variable equation for d. Note that we rewrote the second term under the radical as just x cubed since there was just 0 being subtracted. Now, let's simplify this expression. After simplifying, we get d of x is equal to the square root of x to the sixth plus x squared minus 4x plus 2. Since the function y equals x cubed is defined for all values of x, our domain is the set of all real numbers from negative infinity to positive infinity. We know that d is a continuous function that approaches positive infinity at the ends, so knowing that the domain is all real numbers and that d is continuous with ends approaching positive infinity, we can conclude that d will have an absolute minimum. The minimum distance between the function and the point in question occurs at a critical point of d, so the next step is identifying this critical point by finding the derivative and setting it equal to 0. The derivative of d of x is d prime of x is equal to 3x to the fifth plus x minus 2, all over the square root of x to the sixth plus x squared minus 4x plus 2. d prime of x will equal 0 when the numerator equals 0. The numerator equals 0 when x equals approximately 0.8286. Now substitute the value of x into the original function. Solving for y reveals an approximate value 0.5687. Therefore, the function y equals x cubed is closest to the point 2, 0 at the point 0.8286, 0.5687.